Have you ever wondered how electricity gets to your home? It's an amazing journey that starts with tiny particles and ends with the power to light our world. Everything around us, from the air we breathe to the phone in your hand, is made up of tiny particles called atoms. At the heart of every atom are even tinier particles, protons and electrons. These particles have electric charges. Protons have a positive charge and electrons have a negative charge. When we talk about electricity, we are talking about the movement of these amazing little electrons. Electrons are always on the move, but they need a path to follow. That's where conductors come in. Conductors are materials that allow electrons to flow through them easily. Think of a copper wire. It's a superhighway for electrons. Insulators, on the other hand, are materials that resist the flow of electrons. Rubber, glass, and plastic are good examples. They act like roadblocks, preventing electricity from going where it shouldn't. This difference in how easily electrons move through different materials is what makes conductors and insulators so important in using electricity safely and effectively. Imagine a garden hose filled with water. The water inside is like the electrons in a wire. When you turn on the faucet, the water pressure pushes the water through the hose. Voltage is like that water pressure. It pushes the electrons to move. The more pressure you have, the more water flows. Similarly, higher voltage means more electrons are on the move, and that means more electrical power. This flow of electrons is what we call electric current. Electricity travels in two different ways: alternating current, or AC, and direct current, or DC. Think of AC like a wave going up and down. That's how electricity flows from power plants to our homes. DC is like a river flowing in one direction. Batteries use DC, and it's also used in many electronic devices. Both AC and DC are important for different reasons, and they both rely on the flow of electrons. Electricity is generated at power plants and needs to travel long distances to reach our homes. To do this efficiently, electricity is sent through power lines at very high voltages. Think of it like sending a package across the country. It's faster and more efficient to use airplanes than bicycles. High voltage electricity travels through the airplanes of the power grid and is then transformed into lower voltages for safe use in our homes. Before electricity enters our homes, it needs to be transformed from those high transmission voltages to lower, safer voltages. That's where transformers come in. Transformers are like electricity's shapeshifters. They can either step up the voltage to send it over long distances, or step down the voltage to make it safe for use in our homes. Without transformers, we wouldn't be able to use electricity safely and efficiently in our everyday lives. Once electricity arrives at your house, it goes through a meter that measures how much you use. From there, it travels to your circuit breaker or fuse box. These act like safety guards, protecting your home from electrical overloads. Finally, the electricity flows through wires inside your walls to outlets and switches, ready to power your lights, appliances, and all your favorite electronic gadgets. It's important to remember that electricity is powerful and we need to treat it with respect. Electricity makes our modern lives possible, but it's crucial to remember that it can be dangerous if not handled properly. Always keep electrical appliances away from water. Never stick your fingers or any objects into electrical outlets. Make sure cords are not frayed or damaged. By following these simple tips, you can stay safe and enjoy the many benefits of electricity. From tiny electrons to powerful power lines, the journey of electricity is an incredible one. Understanding how electricity works helps us appreciate its importance in our daily lives. By practicing electrical safety, we can continue to benefit from this amazing form of energy for generations to come.